Hi everyone, this is John Wen. Today is April 14, 2020. I will record this video, briefly talk about the progress I made in the past week. Since current few weeks of finals, a lot of exams and homework due, so I try my best to spare time to read papers and surveys. So here's the highlights. So you can see that the only item updated for the past week is the first item. So the other ones are suspended currently, but I think after these 2 weeks, I will get more time to get back to work on them. So for the first item, to extend the survey, our previous survey to a journal version, currently I'm trying to read the 14 surveys firstly and to get known about what's currently work has been done. And for this week, I work on the survey 10. This is another heavyweight survey that published in ACM on 2013. And this mainly talk about a special kind of workflow scheduling that's called a pipeline workflow scheduling. And this survey is mainly focused on the grid computing, and there's nothing talking about the cloud computing yet, because I think it's published in an early stage, and this paper covers models and algorithm. So you can see that the paper is well structured. I think this overall it's a very good paper for people who want to get known about this grid computing as well as the pipeline workflow scheduling. So you can see in the paper, the author has give a definition of the pipeline workflow scheduling and mainly focus on the scheduling of applications that continuously operate on stream of data set. That means the workflow will run over and over again in different data set, but the assumption is that all the data set have same size. So maybe I think this is a little bit strong to be true in many real case, but this paper has an assumption like this. So the paper is introducing from very basic knowledge like the parallelism techniques, like the task parallelism, the pipeline parallelism, and the replicate parallelism and their difference. So, and also the paper, the survey introduced different examples, like the motivation examples, some real or some example of workflow scheduling that why motivate user to have optimization on the scheduling algorithms or scheduling of the workflow. So I think this part is very interesting, maybe to the new researchers. And also the following, it has introduced modeling tools for the scheduling algorithm, and specifically it divides into 3 parts. The first part is a system model, and basically system model is the first one is workflow model. A workflow model is basically a representation of the workflow, like the DAG, directed acyclic graph, and nodes and edges, what they represent. And also the second item is a system model. Basically it's a computing and the transferring model, like the heterogeneous computing power or the different average communication time. And the third one is about performance model, and performance model is mainly talk about the objective or the performance metric that to assess the performance between different scheduling algorithms. So I think they're kind of similar to what we have in the cloud computing. So the author spent a long paragraph to describe the 3 models. I think this is very helpful for the fundamental knowledge about how the scheduling should conform to the constraints or to the infrastructure that we have either in the cloud computing or for this paper in the grid computing. So you can see the author introduced very detail. Also, very interestingly, sorry, my fan has some issues. If you hearing some noise, that's okay. I'm order component. I think that will be shipped soon. So get back to this paper. You can see even the communication model, it has a different bandwidth model, and one is kind of one port. That means it does not allow a processor to be involved to more than one communication at a time. So maybe this is not true for most of time. So it has another multi-port model for the bandwidth model. So I think, and also it has an in-between model between one port and multi-port. So I think this is very interesting, and maybe that can that gives me more knowledge about there existing a lot of different models, even in the bandwidth. So here is a performance model. Again, we talk about this about objectives and the performance matrix. And here, the author lists out some examples of the scheduling algorithms. Sorry, the scheduling cases that conform with the three types of models mentioned above. And for example, they use different kind of systems and what bandwidth they have. This paper has a very wide range of survey, I think, because they cited a lot of other previous work and give a very brief introduction on each of them. So I think that's a very good thing if people want to have a very wide knowledge by only looking into one paper. So I think that's very helpful. And you can see that the following, it formulate the scheduling problems that trying to build a mathematical formulation of the scheduling problem from a given application. So here it's a chart about the algorithms mentioned in the paper, and in terms of different metrics or the computation or the structure or communication, etc. You can see something very, I think it's a good chart. And there's some example that they are trying to simplify or trying to run a very complex DAG workflow more efficient by building the compact workflow, or we can think about that as a sub workflow that we can reuse every time, even in the different interval or different period, we can reuse sub workflows again and again. So you can see, so it's kind of transition the DAG scheduling to a loop nest scheduling. So I think the loop nest scheduling mentioned here is about kind of reusing in the sub workflows in an incremental way. So it gives some examples, but without further information, I think there does not make sense. Maybe we have to refer back to the origin paper to understand how they works. And so they also call this nested loop scheduling as a cyclic schedule, because we repeatedly use the sub workflows again and again. And also and another interesting thing is about this, they're converting the workflows from a kind of tree, from a graph to a tree representation. So you can see this part, they are giving some examples about different categories or categories of the scheduling problem, like the identical processor with interval mapping. The interval mapping means that the first task and the last task of the workflow can be executed in the same processor or same machine. And they have three different types of mapping. One-to-one is one task on one machine. In internal mapping is first task and last task, a whole workflow, whole sub workflow executed on the same processor. And the general is there's no constraints. So there, in terms of the three types of mapping, and they list out some examples, scheduling examples with graphs, with details, and to talk about how they schedule and what's the purpose, what's the objective, and how they made that. So they give very, I think, very fine-grained classification or categorization of different types. So you can see here, and so here is what I mentioned. So they're trying to convert a series parallel graph to a tree. I think that's for mathematical concern or mathematical convenience in order to compute a kind of optimization based on the workflow we have. So I think this is also very interesting, because currently I'm using the laptop. I'm not able to show you. I also, while I take another class, we're talking about optimization method or software. There is a software called GAMS that's very interesting. If we input the mathematical equations, series of equations, and then it will help us to find a optimization point or a best value point that conforms to every formula. We give some constraints, just like what we have here. So very interesting. Also helped me to get more understanding about the previous paper. I remember there's a paper called the mixed integer algorithm. So that's basically also to convert the workflow scheduling into the formulas, and then put those formulas into a system, and system can calculate the optimal value for you. So that's a side talk. So I think that's very interesting while I read this paper. So you can see from here, the author continue to introduce examples on different examples in the only in the pipeline workflow scheduling, and basically they're trying to make a best way to schedule the schedule the workflow, and then it can reuse some task or save some communication time, and run the data set, same size data set again and again. So this is examples, and follow this. I think they're it introduced they introduced the techniques. They introduced some other techniques, and in terms of the different currently existing method or techniques to schedule the workflows, pipeline workflows. And also it introduced a complexity. It analyze or provide analyze on the complexity in terms of the scheduling, the mapping rules, different mapping rules, and different system models. So you can see here is a graph. I believe here is a graph that summarizes how it the result in terms of different mapping rules and different software system models, like the fully homogeneous communication, homogeneous or heterogeneous. So they're either the NP-hard or the polynomial. So it's similar to this graph. And in the last part, I think they're trying to solve the problems. So as we mentioned before in previous section, it lists out the current scheduling problems and the method how to address them. And here they're specifying the specific algorithms or scheduling algorithm to each of them. And so I think this is exactly the same as the section before. First one is scheduling a chain of tasks with interval mappings. So this is they're trying to list out the current or existing algorithm that in the previous work. So that has addressed this problem, and I think they're very compact because you can see every citation only have one sentence or two sentences, so it covers a very wide range. So also introduce the core functions of these scheduling algorithms. So you can see it goes through different categories in the grid computing, and basically this section has similar structure as the previous section. But first one is mainly focused on the problem, but this one mainly focused on the scheduling algorithms. So, but they have some overlapping, trying to solve the same thing, but the later one is more specifically on the approaches people have used. So you can see their different structures. So overall, I think this is a very good paper in introducing this kind of scheduling algorithm in the grid computing. And I think that's all I will talk about. So yeah, so I think that's all about this survey. So that's all about I will talk about for this video. So thank you so much for your time. Hope you enjoy this video. Until next time, happy coding.